Bismillahirrahmanirrahim. Welcome back to my channel. Today I decided to make a video on web caches, proxy servers, and content distribution network. So here's the scenario. Why do I need? So the question that I'm trying to answer is this: that why do I need web caches, proxy servers, and constant content distribution networks? And what do they do to my network? I mean, how can I save money? So here's our scenario. We have like an institutional router which is connected to a PC, and the link, the transmission rate in that institutional network is about 1 gigabits per second. Then I have an access link which is at about 1.54 megabits per second. So generally in an institute you get a dedicated link from your ISP provider, and then you have like subnetting and all the other stuff going on within the institution. So I have a higher gigabits per second LAN network, and I have an access link which is 1.454 megabits per second of access link. That is connecting me to the internet or the other services which are available on internet, for example like YouTube, Google, Amazon, and other stuff like that. So the scenario is this: that I have an access link that has a rate of 1.54 megabits per second. The RTT from my institutional, so this is this RTT from my router to the servers, from my institutional router to the server is about 2 seconds. So what RTT is actually this. So for example, if I have a client and server, RTT is the time. So if this is a client which is sending a request and this is a router server, if it's sending a request, RTT is the time it takes to send a request and to receive that request. So if this is a request from a client and this is a response from a server, that time is actually known as RTT. So the time it takes for a request to go to the server and being served by a server is actually 2 seconds in this scenario. The packet size that I'm using is actually 100 kilobits per second. This is the packet size, and the average request rate, which means the arrival rate from my browser, from this browser to the origin server, is about 15 requests per second. This is basically a general scenario, and the average data rate to browser is about 1.54 megabits per second. So from my browser to the server is actually about 1.54, even though the link is 1.54 megabits per second, but the average rate is about 1.54 megabits per second. These are the things which are given. So what I need to do, what can I do to find out what is the performance of this network, and what can I do to actually improve the performance of this network if I have scenario which is like this. So the first thing I need to do is actually calculate the utilization of my network. So the first thing I need to do is to calculate my utilization of my access link. So access link utilization, this is the first thing I need to do. So access link utilization, there are different equations, but the one that is being used by Computer Network by Kuros and Ross is actually given as I is equals to L times A divided by transmission rate. So this is the definition we're going to use for utilization of my network. So this is basically traffic intensity. L stands for the packet size, which is 100 kilobits per second. A stands for the arrival rate, or which I mean to say the request rate, how many packets are being requested per second, and R is the transmission rate. So R for access link transmission, this value is going to be 1.54 megabits per second. So once I plug in the values, so this is 100 kilobits per second, 10 times 3 multiplied by arrival rate is about 15 requests per second, everything divided by R, which is 1.54 megabits per second, 1.54 megabits per second. This utilization, when you calculate this turns out to be 0.97, which means my access link, which is this, is being utilized 97% of the time. All right, now I need to calculate the utilization of my institutional link, which is this. So LAN utilization, same thing I'm gonna do. Exactly the same definition, L times A times R. My R is going to be now 1 gigabits per second. So that utilization turns out to be 100 times 10 to the 3 times 15 requests per second divided by 1 gigabits per second, 10 to the 9 bits per second. So that utilization turns out to be 0.0015. Right, so this system is being underutilized. So the LAN, the utilization within my institutional network is about 0.0015, which is less than 1%, which is 0.15%, but this is being heavily utilized. Now if I were to calculate the delay associated with it, so end to end delay, that is a combination of a lot of things. This is going to be a combination of internet delay. That internet delay is given in the problem. That turns out to be 2 seconds. So this is around 2 seconds. Plus I will have some delay associated with my access link. And plus LAN link. So these are the delays I need to associate with to add up what is going to be my delay. Now if I were to look at my access link is 97% utilized. So if I were to look at the delay graph, which is given as something like this, that my delay is less, but as this increases my delay, so this is your delay and this is your utilization. So if my network is 100% utilized, this graph is showing that my delay will go out of bound, which means it will be an infinite delay. That delay in networks, it could be in terms of minutes, isn't it? Because my LAN, my access link is 97% utilized. So according to this graph, what this is saying there, as soon as you hit 1, your delay is going out of bounds, which means this delay is going to be in terms of minutes. So let's say several minutes, let's say 2 minutes. Now if I were to look at this LAN utilization, my LAN is underutilized. That delay, since this is about gigabits per second, I'm going to assume this is going to be somewhere around 2 microseconds or something like that. So this value turns out to be in terms of minutes. This delay is going to be in terms of minutes. So this is going to be about what? 2.22 minutes. That is the delay. So for example, if someone wants to access a video which is being hosted by a YouTube server right here, that needs to go through this link, which according to the 15 requests per second arrival rate, that link is going to be quite busy. So people have to wait for the content to be delivered to this computer. Now what can I do to improve this? The first thing I can do is what? The first thing that I can do is to increase the bandwidth of this link. So for example, if I make this link now to 154 megabits per second, now these delay will tends to go down. Now this, as soon as I will increase my my bandwidth of my access link, this would change to 0.0097 because I have increased this at 100 folds. So this is now 100 times of what we used to have. So this delay is now 0.0097. This will remain unchanged. So now my utilization is less than, here is 0.97%. Here my utilization is 0.15%. So once I change this delay to once I increase my bandwidth, now this delay will change. Now all of a sudden, when I calculate my end-to-end delay, E to E end-to-end delay, now my utilization is less. Still the internet, the RTT is still 2 seconds. Now this delay, which was in minutes, now it will be in some type of milliseconds, which is, let's say, 2 milliseconds, and this will still in microseconds. This will be around 2 microseconds. So now instead of 2.22 minutes, these are some hypothetical values that I have taken. Now the delay will drastically drop to 2.22 2.22 seconds. This is how, once I increase my bandwidth, all of a sudden my utilization will lower my utilization will go down, and based on this, my end-to-end delay, it will be in about seconds. Now, the thing is, in order for me to increase the bandwidth, the institution or the organization has to pay hefty amount. So what can I do? What is the next solution that I can do? So this end-to-end delay with respect to increasing access link rate, all right, which is around 2.22 seconds. So now the next thing I can do, I can install a proxy server right here, or a web caching server. So web cache here. So what is the concept of web cache? The concept of web cache is this. Let's say if an institution, some website or some web page is being requested frequently. So what do? I make a cache, I make a copy at my I make a copy of that page onto my local network. So instead of going all the way from this router to this access link, then accessing the server every time I need to request that page, I have a copy of this. So this being served, this request is being served, instead of going to that origin access link, this is being served within that link, within that network, using web caches. Because the link rate right here, the transmission rate on this network is about 1 gigabits per second. So instead of sending that request to the origin server every time, I can just simply install a web server, a web caching server, and then this will serve by this web cache. If a particular website, or if a particular content is being served, is being frequently requested. All right, so let's calculate the end-to-end delay of this. So the best way to do it is this. So definitely, let's say now here are some of the checks that we need to do. So we're looking at it in terms of web caches. So once we install this web cache, suppose that we have a hit rate or about 0.4, which means 40% of the packets is being served by the web caches, while 60% of the packet, 60% of the request still needs to go to that origin server. All right, so 40% of this being served by my web caches. So now when you look at this particular network, in this network, if the request is coming from this PC, this does not need to go through this access link. This will be served, 40% of the packets will be, 40% of the request or 40% of the packets will be served by this web cache. All right, while 60% of the packets, so this is approximately exactly 40%, and then 60% of those packets, or 0.6, will go to an origin server. So let's calculate the utilization. So I know rate to browser over access link So the average rate that we have given in the question, average request rate from the browser to the origin server, so average data rate to browser is about 1.50 megabits per second. So the next thing I need to do once I install a web caching server is this. So this is going to be 0.6. These are the percentage of packets which needs to still go through that access link to the origin server, times it by 1.50 megabits per second. Once I calculate this number, this turns out to be 0.9 megabits per second. So what I'm trying to do, I'm trying to calculate the access link utilization. So this is 0.9 megabits per second. My access link utilization is going to be divided by 1.54 megabits per second. So out of those 15 requests, 60% of those packets still needs to go through that access link, and that access link has a transmission rate of 1.4 megabits per second, and the average data rate to browser is given as 1.50 megabits per second. So that turns out to be, the utilization turns out to be 0.58. That's how much the utilization will turn out, because this and this will cancel out. You will end up with 0.58. Now 0.58 as compared to an original problem, which is actually 0.97. So you are somewhere in the delay, somewhere around here in this part. So your delay is going to be a very low delay as compared to the previous delay. Now the average delay, so now end-to-end delay when you install a web cache. So install a web cache. Once you install a web cache, that average delay is going to be a combination of all of those delays. So this average delay is going to be 0.6 multiplied by 0.6 are the percentage of packets which are still being served by the origin server. That is going to be plus the time it takes to send a request and to receive a request is about 2 seconds. Plus you get about 1 second from here, about approximately 0.01 from here. So this is just a multiplication of these two, plus 0.4. These are the percentage of packets which are being served by my internal cache, which I just recently installed. So this is going to be somewhere around in milliseconds. So let's say 2 milliseconds. So once I compute this number, this is going to be 0.6 multiplied by 2 seconds. So this is going to be 1.2 seconds plus 0.4 multiplied by 2 milliseconds. This is going to be around 8 times 10 to the negative 4, which is going to be 0.8. So this is about 1.3 seconds of delay. So 3 scenarios we looked at, 1.3 seconds. So this was about, once you increase the bandwidth of this, you were getting a delay of about 2.22 seconds. But once you have installed a web caching server, and where you have a hit rate of 40%, which means 40% of the packets are being served by this web cache. It's actually 40% of the web being served by web cache, while 60% are still going to that origin. Your delay is about 1.3 seconds. So the best option is this: instead of increasing the bandwidth, we can install a web caching server, and based on this web caching server, I can actually tremendously decrease end-to-end delay. So we do that all the time. So we use web caches, proxy servers, and nowadays there is a fancy name for it. The idea is exactly the same. It's content distribution network. We have servers that are serving us with the content. So I don't need to go to the origin server. These content distribution server, like for example, YouTube has different servers located nearby. That's why, so we are being served, instead of going to that origin server, which might be located somewhere in California, hypothetically speaking, I'm being served by a nearby server, hence decreasing the end-to-end delay. That's why YouTube don't buffer anymore. If you remember 5, 6, 7, 8 years ago, when you were watching a video, due to the connection, your speed, your access link, YouTube used to buffer. But nowadays, if you can see, YouTube hardly buffers. The reason is because of these content distribution network, which is the same idea as web caches or proxy server. So I hope you like this small example on web caches, proxy servers, and content distribution network. All of it's the same. Now there's a fancy word for it, content distribution network, but the idea is exactly the same. So web caches are always the best option and the cheapest way to actually to reduce your end-to-end delay instead of increasing the bandwidth. I hope you like this small video. I know it became a lengthy video, but I hope you like this video. And if you have any questions, leave it in a comment section, and don't forget to like and subscribe to my channel.